Good morning, friends. Last we discussed about the nuclear chain reaction. Right? In nuclear fission process, when the slow neutron is bombarded on uranium nucleus, so as a product, a waste 2.5 neutrons are produced as a product, and also at least the more than 20 isotope are also produced, and the large amount of the energy is also produced. This produced neutron further performs the nuclear fission process with the other uranium nuclei, and as a result, at each and every fission process, a waste 2.5 neutrons are produced. This produced neutron again performing the fission process with the other nuclei. So as a result, we obtain the one chain of this reaction. And this process is known as the nuclear chain reaction. Right? Okay. Now in nuclear fission process, what are the neutrons are produced are very fast. Its average energy is 2 MeV. So if all the produced neutron perform the fission process, so this chain reaction becomes the very fast, and at any stage, the very large amount of the energy is produced that cannot be controlled by the human. So it produces the destroyed, that means this reaction acts as a nuclear bomb. And this reaction becomes the uncontrolled manner. Right? So here, today we are going to discuss about that. What are the difficulties arises in nuclear chain reaction or nuclear reactor, and how we overcame these difficulties. Right? The nuclear fission process is used in nuclear reactor, and as a result, we obtain the very large amount of the energy. Okay. So, what are the difficulties arises? First thing, the produced neutrons are very fast. It is necessary to slow down this neutron. And also, the produced neutron cannot escape from the nuclear reactor or without performing the other fission process with the other uranium nuclei. If the most of the neutrons are escaped from the fission material, so process becomes the slow, and at last it becomes the stop. So we can't obtain the energy with constant rate. Right? Therefore, it is necessary to slow down this fast neutron, and also we have to prevent the neutron to escape from the fission material without performing the fission process. Clear it? Okay. Now the second is that it is not necessary to allow all the produced neutron for the fission process. If all the produced neutron perform the fission process, so this fission process becomes the very fast, we cannot control it, and as a result, the destroy takes place. Clear? And third difficulty is that the temperature. During the one fission of the uranium nuclei, the large amount of the temperature is also produced. If the fission process becomes the very fast, so in short time, the temperature becomes the very high, and the explosion takes place. Therefore, the coolant are used. Okay, we are going to discuss the one by one the difficulties arises and also its solution. Right? The question is that here any two difficulties and its solution may be asked for the 2 marks question. In past, the board exam, the whole question is asked for the 4 marks. So for 2 marks, any two difficulties and its removal for the successful nuclear chain reaction or successful nuclear chain reaction in nuclear reactor can be asked for 2 marks. Now, what is the question? Explain the difficulties and the removal in nuclear chain reaction or in nuclear reactor. The following difficulties occurs as the nuclear chain reaction continues to receive the energy at a constant rate. If the nuclear chain reaction is continuing to receive the energy at constant rate, the following difficulties arises. First is in nuclear fission process or the nuclear fission, produce the neutron are very fast. Its average energy is 2 MeV, and fast neutron would escape instead of causing the another fission process. Due to the fast neutron produced in fission process, so there is a more chances to escape this produced neutron from the fission material without causing the another fission process. Second thing, to prevent the escaping the neutron, the wall of the nuclear reactor are made of the concave and with the reflecting materials for neutrons. To prevent the escaping the neutron from the without performing the fission process, the surface of the nuclear reactor are made of the concave and with the material or the reflective material for neutrons. And this neutron produced in fission of uranium-92-238 are very fast. It is necessary to slow down them. If the neutrons are not slowed down, the fission process becomes the fast and process becomes the uncontrolled. So the first difficulty is that during the fission process, what are the neutrons are produced are very fast and its average energy is 2 MeV. The fast neutron cannot escape. Instead of causing the another fission process. To prevent the escaping the neutron from the fission material, here the nuclear reactor are made of the concave surface with the reflecting material of the neutrons. Right? And also, the neutron produced in the fission of uranium-92-238 are very fast. It is necessary to slow down them. If the neutrons are not slowed down, so what's happened? The fission process becomes the fast, and this fission process is out of control. That means the uncontrolled manner. To slow down the fast neutron, the moderator are used in nuclear reactor. Now, as a moderator, the water, heavy water, D2O and graphite are used as a moderator in a nuclear reactor. So here the 1 mark scientific question may be asked. Which of the following material is used as a moderator in nuclear reactor? To slow down the neutron, the moderator are used in nuclear reactor. The water, heavy water, that means the D2O and graphite are used as a moderator. Again, as a moderator in nuclear reactor, the simple water, heavy water and graphite are used as a moderator, that means to slow down the neutron. So here the 1 mark subjective question may be asked from this. Which of the following material is used as a moderator in nuclear reactor, or in other words, to slow down the fast neutron, which of the following material is used? Okay, so that is the first difficulty. To slow down the neutron, and the neutron cannot escape without causing the another fission process. Now the second difficulty, at any stage in nuclear chain reaction, the ratio of number of neutrons produced to the number of neutrons incident at that stage, that is known as multiplication factor K. Again, for successful nuclear chain reaction, the value of multiplication factor approximate nearly 1. First, what is the definition of multiplication factor? At any stage in nuclear chain reaction, the ratio of produced neutrons to the number of neutrons incident at that stage is known as multiplication factor K. Okay. For successful chain reaction, the value of K should be 1. For successful chain reaction, the value of K should be 1. If the K is 1, the reactor is said to be critical. The reactor is said to be critical. And if the value of K is greater than 1, that means the K is greater than 1, the reactor will become supercritical. The nuclear reactor becomes the supercritical. What's happened if the K is equal to 1? The reaction rate and reactor power increases exponentially and explosion destroys the more fission material. So what's happened if the K becomes greater than 1? That means the nuclear is in supercritical condition. The fission process becomes the fast. That means the reaction rate is exponentially increases, and also whatever the reactor power or the energy produced in nuclear fission process becomes the more. So there is the out of control, and as a result the explosion may take place. Right? And if the K is less than 1, the reactor will become in subcritical stage. If the value of K is less than 1, the reactor is in subcritical state. So reaction rate and reactor power decreases exponentially and process eventually stop. If the value of the K is less than 1, the reactor is in subcritical state. So the reaction rate and reactor power is exponentially decreases, and last the process is stopped. So we can't obtain the energy with the constant rate. Right? Okay. So here the second difficulty is that about the number of the neutron produced and number of the neutron incident at any stage. The ratio of the number of neutron produced to the number of neutron incident at that stage is known as the multiplication factor. For successful chain reaction, the value of K, that means the multiplication factor, must be 1. And for K is equal to 1, the reactor is said to be in critical. If the K is greater than 1, at that time the reactor is in supercritical state, and the reaction rate and reactor power increases exponentially and explosion takes place. What's happened if the K is less than 1? If the K is less than 1, the reactor will becomes the subcritical. Reaction rate and reactor power exponentially decreases and eventually stop. For that purpose, for successful nuclear chain reaction, the value of K at any stage approximate 1. So how we control the value of K? Okay. To keep the value of K is 1, the cadmium and boron rods are used. These rods are known as the control rods. Right? So there is also one more important question. Cadmium and boron are the material which absorb the exit neutron. So these rods are used in the nuclear reactor. The position of these rods is automatically. If the process or the value of the K is less than 1, at that time these rods are coming out from the reactor and allow to fission process for the more neutron. If the process becomes a fast, so this rod going inside the nuclear reactor and absorb the exit neutron to keep the value of K is 1. Therefore, the rod of cadmium and boron are known as the controlling rod. Clear? For successful nuclear chain reaction, the value of multiplication factor K must be 1. For that purpose here, the controlling rods of the cadmium and boron are used. The position of these rods of cadmium and boron is automatical. Right? Okay. These rods of cadmium and boron absorb the neutrons to keep the value of K approximate 1. In the reactor. They are kept automatically for longer and shorter wavelength. That means when the value of the K in a reactor becomes more than 1, At that time, these both rods going inside the reactor, that means in a core chamber, and absorb the exit neutron. As a result, the value of the K is decreasing, and when the K becomes the 1, at that time the reactor is in critical state. Right? And when the value of the K is less than 1, in subcritical state, at that time the position of these controlling rods are automatically coming out from the reactor and to allow the more neutron for the fission process. Clear? Okay. If the K is greater than 1, the rods by themselves move inside the reactor, and when the K less than 1, the rods themselves comes out from the reactor, and such rods are known as the controlling rods. So this way, this controlling rods works in a nuclear reactor to keep the value of multiplication factor 1. Right? So sometimes the objective question may be asked, for absorb the neutron in a nuclear reactor, which material is used? For that purpose, the cadmium and boron material are used to absorb the exit neutron. Clear? Okay. Now after that, in a nuclear chain reaction, the enormous, that means the very large amount of the heat energy is produced. And the temperature of the moderator and fission material is approximately 10⁶ Kelvin. That means the 10 lakhs Kelvin. So it is necessary to cool down the moderator and fission material, otherwise the explosion takes place. So it is necessary to cool down the fission material and the moderator. To cool down this moderator and fission material, the coolants are used. The gases, water, molten sodium, etc. are used as a coolant. So here also the one marks question. In a nuclear reactor, which of the following material is used as a coolant? Again, in a nuclear chain reaction, the very large amount of the heat energy is produced, and temperature of the moderator and fission material becomes approximately 10⁶ Kelvin. So it is necessary to cool down the moderator and fission material. For this, the gases, water, molten sodium, etc. are used as a coolant in nuclear reactor. Again, the gases, water and molten sodium, etc. are used as a coolant in a nuclear reactor. So these three main difficulty arises in nuclear reactor or successful nuclear chain reaction. One is first, again we repeat it, the fast neutron produced. It is necessary to slow down, and also the escaping of the fast neutron from the fission material. For that purpose, we are using the moderator, and also the surface of the nuclear core is concave, and the nuclear reflective materials are used. Which material are used as a moderator? Water, heavy water, and graphite are used as a moderator. Second thing is that for successful nuclear chain reaction, the multiplication factor K must be 1. If the K is 1, the reactor is in critical state. If the value of K is greater than 1, the reactor is in supercritical state. Right? If the K is greater than 1, the reaction rate and reactor power increases exponentially, right? And destroy take place. If the K is less than 1, the reactor is in subcritical state. The reaction rate and reactor power decreases exponentially and eventually stop. To keep the value of K is equal to 1, the rods of cadmium and boron are used. These rods are known as the controlling rods. The position of these rods are automatically. Right? If the K is greater than 1, so this rods comes out from the reactor, is going inside the reactor and absorb the exit neutron. And if the value of the K is less than 1, at that time automatically coming out from the reactor, and to allow the more neutron for the fission process. Third difficulty is that in a nuclear chain reaction, the large amount of the heat energy is produced. The temperature of the moderator and the fission material is approximately 10⁶ Kelvin. So it is necessary to cool down the moderator and fission material. And for that purpose, the coolant, the gases, water, molten sodium, etc. are used as a coolant in a nuclear reactor. Now, the fourth difficulty is that the more abundant isotope uranium-92-238 is naturally occurring uranium, is non-fissionable. That means the uranium-92-238 is naturally occurring the uranium is non-fissionable material. When it captures a neutron, then that means when the neutron is incident on the uranium-92-238 nuclei, it produces the highly radioactive plutonium. By the following reaction, when the uranium-92-238, the neutron is bombarded on uranium nuclei, so it absorbs the neutron and becomes the unstable. So here, from unstable uranium nuclei, the neptunium-93-239 is produced. And also, the electron, that means the beta negative beta particle and anti-neutrino are produced. Now this neptunium is also the radioactive itself. It converts into the plutonium, and again the electron and anti-neutrino are produced. So this plutonium is fissioned by the slow neutron. Right? So this process also occurs in a nuclear reactor. Clear this? So there is the difficulties arises in nuclear chain reaction or successful nuclear chain reaction in nuclear reactor, and also the how we overcame on these difficulties. So this question is important for 2 marks. Any 2 difficulties we have to add down with its solution. Okay. After that, the next question is that what is the nuclear reactor? And explain its principle, construction and working. Now, first the definition of the nuclear reactor. A device in which the nuclear chain reaction is controlled is known as the nuclear reactor. Again, the definition of nuclear reactor is a device in which nuclear chain reaction is controlled is known as nuclear reactor. Okay. Now, the nuclear reactor works on the principle of control chain reaction. Again, the principle of nuclear reactor is the control chain reaction process and providing the energy at a constant rate. The principle of nuclear reactor is control manner chain reaction processes and the providing the energy at a constant rate. Schematic diagram of nuclear reactor based on thermal neutron fission is shown in the figure. So there is the core. Here the uranium material is filled. There is the fission material. Here outside of this fission material, the reflector are used to prevent the escaping of the neutron. And these are the control rods made up of the cadmium or the boron. The position of this control rod is automatic. To keep the value of multiplication factor K is equal to 1. Okay. During the fission of uranium nuclei in core region, the large amount of the heat is produced. To cool down the moderator and also the fission material, here the tube are arranged in such a way that the coolant are passing to the reactor to decrease its temperature. And this heat is taken out in a cooling tower. Another tube are arranged in such a way that the steam is given to the turbine. So as a result, the turbine is rotated due to the high temperature or the energy, and we can produce the electricity. Okay, here this tower is known as the heat exchanger. So here the simple water from the condenser is passing through this cooling tower. So as a result, this water is converted into the vapor, and this vapor passing through the turbine. So as a result, the turbine is rotated and electricity is produced. So that is the construction of the nuclear reactor. The schematic diagram of the nuclear reactor on the base of the thermal neutron fission is shown in the figure. Again, what is the nuclear reactor? A device in which the control nuclear chain reaction is controlled is known as the nuclear reactor. The principle of nuclear reactor is control chain reaction processes and providing the energy at a constant rate. And the schematic diagram of the nuclear reactor is shown in the figure. Now we discuss about the working of a nuclear reactor, how it works. Now, what is the construction of the nuclear reactor? The core of the reactor contains the fuel uranium. As a fuel in nuclear reactor, generally the isotope of uranium-92-235, thorium-232 and plutonium-94-239 are used as a fuel of reactor. Just we discuss about the construction of the nuclear reactor. Inside the core, the nuclear material or the fuel material is used. As a fuel material, the isotope of uranium are used, which are the isotope of uranium 92-235, thorium-232 and plutonium-94-239 are used as a fuel material. Now, the nuclear fuel is in the form of rod having the definite mass are kept in airtightly aluminum container. Not directly in a core. The bunch of the fuel of reactor is filled. But here, the nuclear fuel is in the form of the rod having the definite mass are kept in airtight aluminum container. These rods in reactor are kept separate by the moderator. These rods are not connected with each other. Each and every rods of aluminum container are separated by the moderator. So that is about how the fuel material is filled in a core of the nuclear reactor. Now, the heavy water, graphite and beryllium oxide are commonly used as a moderator. These fuel rods are separated by the moderator, and as a moderator, the heavy water, graphite and beryllium oxide are commonly used as a moderator. The core is surrounded by the reflector to reduce the leakage. Already we discussed in the difficulties arises in nuclear chain reaction. The reflector are used, right? The core is surrounded by the reflector to reduce the leakage of fast neutron. The heat released in fission is continuously moved by the suitable coolant. Already also we discussed the coolant are used to cool down the moderator and also the fuel material. So here the heat released in fission is continuously moved by a suitable coolant. Right? A reactor prevents the escape of the radioactive fission product. Due to the fission process, what are the product is produced? The reactor is also prevent the escaping of this radioactive fission product from the core material. The reactor can be shut down by the rods made up of cadmium and boron that have the high absorption of the neutrons. Already we discussed about the control rods. These control rods are placed in the core. Its position is automatically coming out or inside the core. To keep the value of multiplication factor K is equal to 1. Right? To stop the nuclear reaction, here the control rods made of the cadmium and boron that have the high absorption of the neutrons. So we can stop the nuclear chain reaction by inserting this controlling rod in a core. So all the neutrons are absorbed by these rods. The coolant transfers the heats to a working fluid which in turn may produce the steam. The steam drives the turbine and generates the electricity. What are the heat is produced in fission for the nuclear reactor? This heat is transferred by the coolant and this turns the turbine or the drives the turbine, and as a result the electricity are produced. So that is the working and also construction of nuclear reactor. Clear? Okay. Now, what are the uses and disadvantages of nuclear reactor? So we know that there is the dangerous nuclear process, fission process take place inside the nuclear reactor. Why we are using to produce the electricity only. Now the uses of the nuclear reactor are, the usage first, the reactor prepared the radioactive isotope or the radioisotope that can be used in scientific research, medicine, agriculture and industries. So as a waste, what are the radioactive isotopes are produced in reactor? This reactor is used in scientific research, medicine, agriculture and also the industries. Right? So what are the products or the fission product as a waste or the nuclear waste during the nuclear reactor or the nuclear fission process? What is the waste is produced? This waste is used in scientific research, medicine, agriculture and also the industry. Second is useful for generating the electricity. We can produce the electricity by the nuclear reactor because the very large amount of the heat is produced. This heat is transferred by the coolant and this coolant drives the turbine and as a result the electricity is produced. Now third use, the useful for the producing the fast neutron needed for the nuclear bombardment. So nuclear reactor is also produce the fast neutron. This fast neutron is required for the nuclear bombardment or the nuclear projectile. Right? These fast neutrons are known as the projectile particle. And fourth use is the nuclear reactor is useful for making the plutonium which is used in atomic bomb. To prepare the atomic bomb, the plutonium is required. For this plutonium, how we prepare the plutonium? From the nuclear reactor. Therefore, the nuclear reactor is useful for making the plutonium which is used in atomic bomb. Now, what are the disadvantages? The fission process in nuclear reactor generates considerable waste product. In nuclear reactor, already we discussed about the fission of uranium nuclei by the slow neutron. Approximate more than 20 isotopes of uranium are produced. These are also the radioactive. And as a waste, we obtain more than 20 isotopes of uranium and these are the radioactive. Second is, this nuclear waste need the special care since they are radioactive and hazardous. So this waste produced during the nuclear reactor or the nuclear fission process require the special care. because these wastes are also the radioactive and also the harmful. And third is for reactor operation, handling and reprocessing the spent fuel is required. For the working of the reactor, for the operation of the reactor, handling and also reprocessing, the extra fuel is also required. Extra fuel is also required. And fourth disadvantage is that an appropriate plan is being evolved to study the possibility of radioactive waste into less active and short-lived material. So what are the wastes produced in the nuclear reactor? Some isotopes are long-lived and also the radioactive. So here, the plan is also required to study the possibility of the radioactive waste into less active and also the short-lived material. So within the short time, then it becomes the non-active. So this type of the plan is also required for the nuclear reactor. So these are the uses and this is the disadvantages of nuclear reactor. Sometimes in objective question or short time 2 marks, sometimes the 2 marks question may be asked to handle the uses and disadvantages of nuclear reactor. And also we have to also familiar with that what are the uses of the nuclear reactor, not only the purpose of the nuclear reactor to produce the electricity. So what are the wastes produced in the nuclear reactor are also used in scientific research, medicine, agriculture and also the industries to produce the electricity and to produce the fast neutron. Fast neutron is also helpful for the bombarding, nuclear bombarding. To prepare the nuclear bomb, here the plutonium is also required. To prepare the plutonium, we have also required the nuclear reactor because as a waste product, the plutonium is also produced. Right? Okay. So these are the uses and disadvantages of nuclear reactor.